first, let me introduce myself. My name is Sitaka Tipati, 6005512. So, what me and my friend gonna do today? Today we're gonna classify the mammographic mass of dataset by using SVC technique in machine learning. But firstly, let's talk about the basic knowledge about SVC technique and machine learning. So, let's come and see.
Machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from excellence without being explicitly programmed. Machine learning focuses on the development of computer programs that can access data and use it learn for themselves.
Machine learning algorithms are often categorized into two categories, which are supervised and unsupervised. For the first one, supervised, it can apply what has been learned in the past to new data using labeled examples to predict future events. Moreover, it can also compare its output with the correct ones and find errors in order to modify accordingly. Next, unsupervised. These algorithms are used when there is no label information. It studies how systems and infer a function to describe a hidden structure from unlabeled data. Machine learning has various disadvantages and advantages, and these are some of them. For advantages, the first one is supplementing data. Machine learning doesn't only automate the analysis of big data, but also provides assumptions to support decisions. Next, continuous improvements. Not only prediction making from the historical data, it will continue repeatedly acquired data to improve its analytic patterns. The last one is about automation of tasks. Machine learning system has been developed to perform tasks on their own. There are three advantages of the machine learning. The first one, error diagnosis and correction. Every machine has errors. Next, time constant in learning. It's impossible to make immediate, accurate predictions with the machine learning system. Of course, when they are bigger the data, it will take longer process. The last one, limitations of prediction. Machine learning system cannot always provide rational reasons for a particular prediction or decision.
Support vector machines or support vector classifier is a discriminative classifier formally defined by a separating hyperplane. In other words, given level training data or supervised learning, the algorithm output an optimal hyperplane, which categorizes new examples into dimensional space. This hyperplane is a line dividing a plane into parts, wherein each class lay in each side.
The advantages of support vector machines. The first one is it works really well with clear margin of separation. The second one is it is effective in high-dimensional spaces and the cases where number of dimensions is greater than the number of samples. And the last one is it uses a subset of training points in the decision function, so it is also a memory efficient. Next is the disadvantages. It doesn't perform well when we have large dataset because the required training time is higher. And also with a dataset that has more noise, like target classes are overlapping. And SVM doesn't directly provide probability estimates. These are calculated using an expensive file flow cross-validation. It is related SVC method of Python scikit-learn library. Support vector classification are classes capable of performing multi-class classification on a dataset. SVC and new SVC are similar methods, but has a slightly different set of parameters and have different mathematical formulation. On the other hand, linear SVC is another implement of support vector classification for the case of linear kernel. The dataset that we chose is Mammographic Mass dataset, which can be downloaded from UCI Machine Learning repository website. This is data information and the class distribution. There are two classes in this dataset, which is benign and malignant. For the attributes, there are 6 attributes. And this one is our goal. We will classify this using machine learning. There are missing values in this dataset as well. For this section, we will explain our code step by step. The first step is to read the dataset file and declare the missing value. If we open the file that we downloaded from UCI website, you can see that there are a lot of missing value and they are denoted by the question marks. So we have to declare the question mark as a missing value. And then we will read the file by the command pd.read_csv. We have to specify the name of each column and also the missing value. So if we type the command df.head, we will obtain the first 5 rows of our data frame df, which contains 6 columns right now. The second step is to clean the data. We firstly check if any weird data are in each column by using the command df.groupby column name .size. This command will show the frequency of what's in the column like this. For the column bias assessment, we found 17 weird data, which are 5, 0, 11, 6, and 155. According to the data information for UCI, the assessment is supposed to be an integer between 1 to 5. So we will deal with this weird data by setting 55 and 6 to be a missing value using np.nan. numpy.nan. Okay. And for 0.0, we will change it to be 1 because there is no 1 in this data and it's supposed to be 1 to 5, right? So 0 could be a typo, so we use the command like this to change it. We use the f.location. After checking the rest column using the same command, we did not find any other weird data. So next we will delete all the missing values because we think that the data with some factors are unknown should not be used or replaced with the mean or overguessing values. Using those data might distort the result we obtain. These are all missing values we have each column. There are many missing values. We use the command df.isNow.sum to obtain this result. We will use for loop to delete the row that contain missing value. This is the result after we delete the row. We have no missing value left in the data.
Next step, we will plot the graphs to see how each factor interacts. In the class, we use the command plot or subplot for Matplotlib plot module, which need a lot of lines to plot all the graphs because our data set has many attributes. So we did the self-study and found the easier way to plot the graph. We will use pair plot from Seaborn instead, and the result is shown here. You can see there are lots of graphs are plotted. Okay, we use this code to plot the graph. The blue dot is for the class benign, and the orange plot is for the class malignant. By observing the graphs, you can always see that the higher bias assessment, this one is higher bias assessment, will classify as malignant, similar to looking at the age. This is the graph of age and bias assessment. According to the pair plot, we have chosen 3 graphs that we can see the classification most clearly, which are bias and age, shape and age, and margin and age. We will use the technique that we learned in the class. We use subplot style to plot the graph, and this is the output. The next part is the machine learning process, which we firstly split the test data and train data. We started by using the test size of 30%. We use SVC technique and also check for accuracy of the prediction. This is the output. The accuracy we obtain for this test size 30% is 79.27. We also want to know what is the test size that will maximize the percent accuracy, so we create the for loop to find out this. And also plot the graph showing the relation between test size and percent accuracy. The loop will run from the test size of 1% to 95% with a step of 0.1%. This is the result we obtain. The maximum accuracy for using SVC for this data set is 85%, 85.31%, with the test size of 17.040%.
In conclusion, we select the method of machine learning to classify severity of the mammographic mass by using SVC, and then we find the maximum accuracy. Firstly, we use test size of 20%, and the accuracy that we obtain is 79.27%. Then we try to find approximate test size that will get the maximum accuracy. The result is test size of 17.4%, and accuracy that we obtain is 89.31%. Considered as good accuracy, SVC offers high accuracy compared to other classifying, and the concept is relatively simple. However, human input is still important to better evaluate the outputs of this system. Thank you for watching.